Why don't wind turbines always produce maximum energy? Imagine a wind turbine spinning gracefully in the breeze, eager to generate electricity. But sometimes, it seems to be working harder than usual, and other times, it's barely turning. Have you ever wondered why wind turbines don't always produce their maximum energy? Well, let's explore what influences their output and why they can't always hit that top mark. First, wind itself is unpredictable. Wind speed and direction change throughout the day, across different seasons, and from year to year. Wind turbines only generate power when wind speeds are within a certain range. They start producing electricity at around 7 miles per hour and stop if wind speeds go above 45 miles per hour to prevent damage. So, if the wind is too slow, the blades don't spin enough to generate much power. If it's too fast, safety systems shut down the turbine. This means the amount of energy they produce varies constantly with the weather. Second, location matters a lot. Some places have steady, strong winds like open plains, coastal areas, or mountain passes. These sites are ideal for wind energy. But even in the best spots, there are times when wind drops and turbines produce less energy. In areas with less wind, the output is even more inconsistent. That's why wind energy often needs backup sources to keep the lights on when the wind isn't blowing. Third, turbines need regular maintenance. Over time, parts wear out or need lubrication. If a blade gets damaged or a gear needs fixing, the turbine might slow down or stop temporarily. Larger turbines are more efficient but also more complex, which can mean longer downtime during repairs. This maintenance can reduce the total energy a turbine produces over its lifetime. Fourth, connecting turbines to the power grid adds another layer of complexity. Even when turbines are working well, the electricity they produce must match what the grid needs at that moment. If wind suddenly drops, other power plants must quickly step in to fill the gap. This balancing act can cause turbines to run below their maximum capacity or shut down temporarily. Fifth, economic factors also influence energy production. Building a wind farm costs a lot upfront, sometimes hundreds of millions of dollars for large projects. The cost of materials like steel and rare earth elements can fluctuate, affecting the overall project costs. While wind energy is often cheaper over time, these costs can limit how many turbines are built or maintained. Finally, environmental and community rules can restrict turbine operation. Concerns about noise, visual impact, or effects on wildlife sometimes lead to limits on where and how turbines can operate. These restrictions can reduce the total energy output of a wind farm. To measure how well a wind farm is doing, utilities use something called the capacity factor. This is the ratio of actual energy produced over time compared to the maximum possible if the turbine ran at full power all the time. For most wind farms, this is between 20 and 40%. That means turbines are producing only a fraction of their maximum potential most of the time. To work around these challenges, utilities often combine wind with other energy sources, use weather forecasting to predict output, and invest in energy storage systems. Wind energy is a vital part of the energy mix, but because it depends on natural conditions, it can't always produce maximum energy all the time. That's why careful planning and management are needed to keep the electricity flowing smoothly.